Hello and welcome to this GCSE Foundation Tier lesson 11.7, looking at finding the areas of circles. Okay, for your do now task we have 3 questions finding the circumference or perimeter of the shapes. There are 3 questions and an extension. Pause the video while you have a go at those. Remember to show all you're working out and remember to think about the units at the end. Okay, having had a go at those, I think the first answer is 15.1 for the circumference, centimetres. B, the perimeter this time is 21.5 metres, that's pi times 5.2 plus 2 lots of 2.6 because the radius is 2.6 metres. And the third one, it's half a circle, so it's half the circumference plus 14 for the diameter. So 36.0 metres to 1 decimal place. If you've tried the extension, once round is basically the circumference, so to the nearest metre you should have 44 metres. Okay, moving on. Bronze is to recall how to find the circumference of a circle. You all should have just done that anyway. So we're moving on to silver to be able to calculate the area of a circle, and gold to be able to solve problems by calculating the area of the circle. Okay, so let's move forward. Right, this is vital for your book. The area of a circle is pi times the radius, and we write that mathematically, technically and nicely as area equals pi r squared. Pause the video while you write that down. You might want to draw a circle and just outline the radius on your diagram. Okay, so let's make sure we can know what we're talking about. So here's a circle with a radius 7 centimetres. We've got the formula at the top right there, and again you do need to learn the formulas. It's not given to you, so you need to learn it. So we've got area is pi times the radius squared, or pi times 7 squared, which is pi times 49, and there's your long decimal, and you round it to 1 decimal place. Don't forget to put centimetres squared. That's certainly an example worth putting into your book. It's worth noting at this stage that using your calculator you can just type pi times 7 and then the squared button equals and do it in one go on your calculator. But always I would recommend you write the long decimal down and then you round it. Pause the video while you do that. Okay, so here's a second example. Pi times 5 squared, that's pi times 25. There's your long decimal, and that rounds to 78.5 centimetres squared to 1 decimal place. You wish to copy that one down, pause the video. Okay, here's the third one. This time hopefully you can all work out it's going to be pi times 2 squared. And there's your answer, 12.6 centimetres squared. That should be straightforward. Might be one more, I thought there was. So here we're going to go pi times 4 squared, pi times 16, and rounded to 50.3 centimetres squared. Remember, don't forget to put the long decimal down before you do the rounding. The reason we say that is it's probably worth 3 marks, and if you get to there and write the long decimal down, you've got 2 marks, and then the final mark is for rounding. If you round wrongly and you haven't put the long decimal down, you only get 1 mark rather than 2. But obviously we want 3. So, here's one more. That should be pi times 9 squared. We'll skip that one quickly, that was yet another one. So, pause the video while you have a go at these, please. Draw the circles out, show you working out, show the long decimal, and then round your answers to 1 decimal place, please. Okay, so here are the answers I got when I've worked through them. 28.3 centimetres squared. There's B. A stands for area, not BA, letter A. 50.3 centimetres squared. 19.6 centimetres squared. 38.5 centimetres squared. 78.5 centimetres squared. 26.4 centimetres squared. And then finally 55.4 centimetres squared. Pause the video while you make sure you mark those accurately, please. Okay, so, how do we find the area of this one? Well, the area is pi r squared. So what's the radius? I know. The radius is 9 centimetres. And then we're off. Pi times 9 squared. Pi times 81, 254.5 centimetres squared. So just be careful whether you're given the diameter or the radius on the diagram. Let's look at the next one. Here it is. What's the radius? Hopefully you're shouting out 8 centimetres. So therefore it's pi times 8 squared, which is 201.1 centimetres squared to one decimal place. It's worth copying one of these two examples down, I think. Pause the video while you do that. Okay, so this is up to you now. Look carefully. If you look at them, I think they're all given as diameters, so be careful. Work your way through them. Pause the video, draw the circles out, show you're working out, write the long decimal down, then round it to one decimal place, and don't forget to put centimetres squared on all of them. Okay, so this is our silver learning. Let's check how we got on. There's the first answer, second, C, D, E, F, G, and finally H. Make sure you pause the video while you mark all your answers, please. Okay, so what would you do if you were working out the area of a semicircle or a quarter circle or 3/4 of a circle? Like that, or that, or that. Well, what you do is work out the area of the whole circle and then find the fraction that you need. So you might, if you want to half it, you'd divide it by 2. If it's a quarter, you would divide it by 4. And if it's 3/4, you'd multiply it by either 3/4 if you use your fraction button on your calculator, or 0.75. And I think what follows next is an example. So there we are, there's the shape that I was thinking of. If we say that the radius is 7 centimetres, we work out the area of the whole circle, like so, which I've rounded at that point to 153.9 centimetres squared. The green section is 3/4 of it. Now 3/4 is 0.75, and then you round it at the very end, 115.5 centimetres squared. Now a little tip for you, when you've got that pi times 49 on your screen, 153.93804, and there were many more decimal places, leave that on your screen, and then when you've written the second bit out, just do that times sum the other way round. So do your answer on your screen times 0.75. That way you'll get the most accurate answer. It might be worth your while copying that one down. If you're going to, obviously pause the video to do that. Okay, so this is question 4. There are 6 of them. Notice the units, sometimes metres, sometimes millimetres, sometimes centimetres. Hopefully I got them right on the next slide, putting the right units on, but we never know. These are the gold ones, the ones that are more challenging. Draw the diagrams out in your book, pause the video whilst you have a go at them. Okay, so how did you get on with those? There's my first answer. Second one, I've got the units right so far. Third one. Fourth one, D, E, and F. Pause the video whilst you check them, please. For once I did get all the right units. Okay, so what about this one? Find this shaded area. Well, it may not look like it. Look, we sometimes call it a ring, or the posh word I think is annulus, but it's basically a big circle minus a small circle. So we find the area of the big circle. Well, on the big circle, from the centre of the shape to the very edge, would be 4 meters. And then we've got 3 for the inside. I think that should be pi times 5 squared actually, but never mind. So pi times 16 minus pi times 9, which is 7 lots of pi, which would be 22.0 centimetres squared. I do think that should be pi times 5 squared minus pi times 3 squared, so slight error there. Sorry. Okay, what about this one? This is definitely the big circle minus the small circle. So pi times, oh look, those are given as diameters. So we need to think carefully and get the radius for each one. So pi times 4.5 squared, that's the half of 9, minus pi times 2.5 squared. And I've squared each number and then took it away, but you can just use your calculator to work it all out. You should end up with that decimal, which is 44.0 centimetres squared to one decimal place. If you want to write that one down in an example, please pause the video and do so. There will be some challenging gold questions coming up, no doubt. Okay, so this is a tough question, or it looks like it's a tough question. But think, what could you do to that small semicircle on the right there? What could you do to it? Thinking about that gap on the left hand side. Pause the video while you have a go at those. Okay, so let's see how we got on. Here's my working out. The radius of the big semicircle would be 2 centimetres in the first bit, because the radius of the small one is 1, so the big one will be 2. So the shaded area is pi times 2 squared divided by 2, because that bottom little semicircle fits exactly into the left hand semicircle where the gap is. So altogether you've basically got one semicircle. That's why I'm dividing by 2. So there's my answer for that one, 6.3 centimetres squared. And then B, these are my answers. I haven't got room for all the working out for B part 1, part 2 and part 3. And you did particularly well if you managed to work out this last bit, which I don't think would be on a foundation tier. But the area is 2 times pi times the radius squared. I don't think I'd worry about that one too much. Okay, so let's have a quick look at our learning objectives for this lesson. To be able to recall how to find the circumference of a circle, well, we did that. You managed that during the do now task. You've found the areas of several circles in the middle of the lesson, that's the silver, and you've been solving some problems at the end, some quite complicated ones for your gold learning. So well done. Please remember to check to see if there's any purposeful practice work or any Hegarty maths work to be completed. I'm sure there will be. But well done, and I'll see you next time.